are going to start today kind of remembering what we just recently came from and the really important lesson that we did right before our break. And so here we go. So, the big thing that we were talking about before our break is that, you have this parent population, okay? The population. And that's the big thing to know is this is all of the data. But then when we dropped down samples, so say I randomly selected the data from the population and then I averaged it and I dropped down one of these X bars. So that was our sample average. Then I had what was called a sampling distribution. So when you took these X's and you made an X bar and you dropped it down, we don't have the population anymore. We now have this thing called the sampling distribution. So what matters to us is if we have a small sample size, okay, and you can see here that 4 would be considered a small sample size. So do we have a small sample size or do we have a large sample size? And for means, a large sample size would be greater than or equal to 30. So if I come on down here, then look at what happened, when we had this large sample size, meaning that the data, so like when you did your timer, that's why I had you do 30 times that you had to find your average, okay? So that you had an X bar that was down here. You had one of these X bars so that I knew then that our distribution, when I put all of our data together, which I actually still have to do that, and then I'll make a video showing you our results, but all of our data together came out to be that. Okay. So remember, large sample, is your sample size large or is your sample size small? And so again, large sample size. Okay, so, and again, the conclusion that we came to was, and I'll zoom this out so you can see, was this, that even if we do not know the shape of the population, this top part here, okay, even if we do not know this shape, or if it's a really unusual shape, okay, then if you drop down samples that you average, and they are, if you drop down samples that you average, that's my alarm to do to do my attendance. Then you are not going to have, you're going to have small sample sizes that will not look pretty. You can't count on this coming out to be something that we can do normal model math with. But the big idea is that if I have a large sample size, meaning I took more than 30 randomly selected pieces of data from this population, and I averaged them together, and I dropped them down here and got one of those averages down there, okay, then I can count on, because of that thing called the central limit theorem, I can count on this becoming approximately normal, okay? That's the big deal. Now, we talked about, in relation to this, what is the center? So what is the mean? So we found that the means stayed the same, even on the small sample size. So you had the population mean, the small sized samples sampling distribution, and the large sized samples sampling distribution. They all had the same center, but you clearly noticed that they had different spread. Okay, and even this population has a higher standard deviation because you have more data on the outside edges. So that's more data that is farther away from the mean, making it a bigger standard deviation. This one got smaller standard deviation, and this one was even smaller still standard deviation. All right, so those two main things. The mean stayed the same, but as your sample size got larger, your standard deviation, your variability got smaller. Okay, so now let's put this to math problems. But I think before we do that, the first thing I want to do is we have just got to make sure that we have a solid understanding of what all the different letters stand for. Okay, so that's what we're going to do next. On your assignment, you actually have this, which you're going to be doing where you're going to be matching up these definitions, over here then with these items. But I'm going to do that. I'm going to practice that with you without practicing it on here. And I didn't have separate notes. So sorry about that. But we'll just talk through it and we'll see how you do. All right, so here we go. So let me move my picture out of the way. So here we go. So let's talk through our options. Now, let's just kind of examine the letters, the ones that have P's in them. So this is a P hat. Let's compare it to this plain P. And then I see I've got a mu with a P. And then I think I've got a P hat. And then I've got a standard deviation of the P hats. Okay. So let's talk about it. Okay. What do you remember? This one that is a P hat? That was your particular sample results. Like when you got your blue M&M proportion, that was your P hat. So that was your sample proportion. So that's what this one is a sample proportion. Okay. Now, this is what the factory claimed that sample proportion to, all the blue proportion of all blue M&Ms to be. And so if that's the proportion of all blue M&Ms, then that's going to be the population proportion. See, sample versus population. So that one is E. Okay. Now, what the heck is this mu of p hats and standard deviation of p hats? Well, remember, the mu of p hats is where we expect all of our samples to be centered. So that is the mean of all of the p hats. So that's the mean of the sample proportions. I think I see that right here. The center of all of the sample proportions. So that's K right here. And then here is how varied they would be. How varied are our sample proportions? That would then be that standard deviation of all of the sample proportions. So that's letter I. Okay, so there's where we are. We got the proportion ones. So I'm going to even show you this in a different color. Let's do the ones that have to do with means. Now, so what I see also that we need to talk about, first of all, let's actually just start here. A plain X. Do you remember when we had this picture here? See, those plain X's were just one individual piece of data. So that's what the X's are, that one individual piece of data. So I think there it is right there. B, that one individual piece of data. Now, how is that different from X bar? Okay, so on our stuff here, remember an X bar was when we had taken several of these X's up here and we averaged it and dropped down an X bar. So that's the mean of our sample. You all told me your own personal X bars. You told me your personal X bar, let's see, sample mean. So that was the letter C, sample mean. Okay, you told me your own personal X bars, and that was your average of your 30 times on the timer. Okay, now I'm going to erase this little picture because we're talking about means now instead of proportions. So if I had this distribution and I had a lot of X bars in it, then where would I expect all of your X bars and my X bar and all of our sample results, sample means to be located? Well, at the mean of those X bars. So that would be the center of them. So the mean of the x bars is, where is that? Oh, here it is. The mean of all of those sample means. Okay, so that's J. All right, and then of course here's the standard deviation. How varied this stuff down here is. Okay, how varied the same. So standard deviation of all sample means is H right here. Okay, cool. Now, a couple other little straggler things let's take a look at. I'll do this in a different color. So we've got this N, regular old N. Hopefully you know what that is. That is your sample size, so that's A. And then what about this plain sigma? It doesn't have a subscript like the other ones. It's just plain. Well, that's because it's the original population one, how varied all of the individual pieces of data. All of your 5,400 individual times vary this much. Okay, and so that is the population standard deviation. That's here. Standard deviation of the population. So that's G. And then, of course, this one here is going to be the standard deviation, the mean of the whole population. Population mean. So that's F. Okay. So there is a practice to go through without you being able to reference it, I guess, because now you're going to practice that here on this right here. Okay, so they're in a different order. And then over here, the definitions are different. So all the letters will be different when you do this part of your assignment. But hopefully I showed you and demonstrated to you what those things represent so that you can have a good idea of that. All right, so I'm going to stop this video right here before we actually get into practicing one of these problems that you're going to be doing. So let's end that video there. Let you practice that that first page of your assignment. See if you can get all of those things correct, and then we'll move on to the problem.